Comet 3I/Atlas, a newly discovered visitor to our solar system, has captured global attention not only because of its remarkable physical properties, but because of the deep mysteries and unsettling questions it raises about the nature of interstellar objects. Identified by the Atlas telescope in Chile on July 1, 2025, the object immediately stood out due to its hyperbolic trajectory, a rare feature that confirms it was not born within our sun's gravitational family. Instead, it came from the vast and unknown expanses of interstellar space, passing through our cosmic neighborhood for reasons we can only speculate about. As it approached its perihelion on October 29th, at a distance of roughly 1.4 astronomical units from the Sun, astronomers and scientists around the world intensified their observations, hoping to learn why this object behaved so differently from typical comets. NASA JPL even released an animation showing its path cutting cleanly through our system, emphasizing both the elegance of its motion and the peculiarity of its origin. What made 3I/Atlas even more intriguing was that existing missions, including China's Tianwen-1 spacecraft, launched in July 2020 and deployed around Mars since early 2021, were fitted with instruments capable of tracking fast-moving objects like this one. As data accumulated from multiple sources, including ground-based telescopes and deep space probes, curiosity began to shift into concern as several anomalies emerged in the comet's composition and behavior. Some scientists, including well-known astrophysicist Avi Loeb, began drawing an analogy that sounded more like myth than astronomy: the legend of the Trojan horse. In the ancient story, an object that appeared harmless on the outside concealed a hidden danger within. Loeb and others proposed a provocative question. Could 3I/Atlas be following the same pattern? Could it be disguising a technological interior beneath a natural, dusty shell that resembles an ordinary comet? These ideas were framed as rhetorical, not as claims, yet they resonated strongly with the public, especially given the object's arrival close to Halloween. The timing encouraged even more imaginative comparisons, as if the comet were wearing a costume, hiding its true nature while presenting itself as something simple, frozen, ancient, and perfectly normal. While most astronomers prefer grounded scientific reasoning, the mystery surrounding 3I/Atlas only deepened as more measurements came in, and the comet refused to behave in expected ways. Traditional comets follow predictable paths and display familiar characteristics: volatile ices vaporizing near the sun, dust tails pointing away from solar radiation, and chemical compositions that match the primordial materials of the early solar system. But 3I/Atlas diverged from this pattern in several striking ways. First, its composition showed an unusually high concentration of nickel, far beyond what is typical for natural comets. This raised immediate questions. Nickel, being a heavy metal, suggests processes involving intense heat, pressure, or even manufacturing, since many technological alloys used in spacecraft engines and structural components include nickel for durability and resistance to extreme environments. Although natural explanations exist for nickel enrichment, the levels found in 3I/Atlas exceeded those recorded in known samples of cometary material, giving weight to the idea that this was not an ordinary object drifting aimlessly through space. Second, the stability of its trajectory puzzled mission analysts. Most interstellar visitors, such as the earlier objects 1I/Oumuamua and 2I/Borisov, experience subtle but measurable deviations in their paths due to outgassing or external gravitational influences. These deviations, though small, are expected for icy bodies shedding material as they warm. But 3I/Atlas maintained a remarkably precise trajectory, as if guided or corrected by an internal mechanism. This level of stability is atypical for a natural comet, leading scientists to theorize about possible explanations ranging from unusual physical cohesion to non-natural steering capabilities. The debate about these possibilities quickly spilled out of academic circles, with enthusiasts and skeptics alike trying to interpret the growing collection of anomalous data. Perhaps the most extraordinary element of 3I/Atlas was the development of a second tail, something no known comet produces in such a manner. While comets often display multiple tails, including dust tails and ionized plasma tails. These typically point away from the sun due to solar wind and radiation pressure. But 3I/Atlas generated a second tail that extended in the opposite direction of its motion, a phenomenon that defied conventional models of comet behavior. A tail pointing forward rather than trailing behind would require an active force or emission of material from the rear of the object, almost like propulsion. If this interpretation were correct, it would imply intentional maneuvering, or at least some technological process beyond the capacity of natural physics. That single observation dramatically intensified the mystery, prompting new questions about whether the object might be releasing small probes, adjusting its course using solar heating, or conducting actions that only advanced technology could achieve. Scientists who entertain such possibilities remain careful in their language. No one can conclusively declare 3I/Atlas to be artificial. Yet the combination of a hyperbolic interstellar path, high nickel content, stable trajectory, and an unprecedented second tail pointing forward has made it one of the most unusual cosmic objects ever studied. Supporters of the artificial origin hypothesis argue that if an extraterrestrial civilization wished to explore star systems discreetly, they might construct probes camouflaged as natural objects. The exterior could consist of comet-like dust, ice, and debris to avoid detection, while the interior housed instruments or mechanisms capable of propulsion, navigation, or data transmission. In this scenario, approaching the sun would provide both a gravitational assist and a source of heat energy, enabling the object to activate dormant systems, deploy observational devices, or alter its course before continuing to another destination. Skeptics counter that extraordinary claims require extraordinary evidence, and the anomalies observed could still be explained by rare but natural processes. They point out that cometary behavior is diverse and not completely understood, especially for objects originating outside our solar system. Chemical compositions vary widely, and interactions with solar radiation can sometimes produce complex structures or trajectories that seem unnatural. They also caution against anthropomorphizing or projecting technological motives onto an unknown interstellar traveler without concrete proof. But even among skeptics, curiosity remains high because the list of unusual characteristics continues to grow. The Tianwen, one mission's involvement adds another layer of intrigue. Originally designed to study Mars, its instruments were unexpectedly useful for tracking objects like 3I/Atlas. As it monitored the comet's approach, its sensors collected data that reinforced some of the unusual findings already reported by Earth-based observatories. Other planetary missions and satellites also contributed to the monitoring effort, turning the comet's arrival into an international scientific event. Although most of the collected data remains preliminary or undergoing analysis, the global effort to understand this object underscores how significant and rare it is. The comet's passage during the Halloween season only amplified the aura of mystery surrounding it. For the public, the imagery of a strange, fast-moving interstellar object wearing a mask of cosmic dust like a costume made the event feel almost scripted, as if the universe intentionally timed it to provoke fear, wonder, and speculation. But for scientists, this coincidence served mainly as an emotional backdrop to an object that would have demanded our full attention regardless of timing. Whether 3I/Atlas is a natural relic from a distant star system or something more engineered, its presence challenges our understanding of interstellar dynamics, the nature of cosmic visitors, and the possibility that our solar system is being observed by something far older, more advanced, or more mysterious than we imagined. As it continues its journey, leaving behind theories, excitement, and debates, humanity is reminded that the universe still holds countless secrets. Some objects pass silently through the night sky without notice, while others, like 3I/Atlas, force us to reconsider everything we think we know. The truth about its origin may remain hidden for years or even decades, but its appearance has already sparked one of the most fascinating scientific conversations of our time.